All right, in this section we're going to cover what's called the predator-prey model. Okay, it turns out we can set up a system of equations to model the populations of predator and prey. So let's let x of t equal the prey population. So we'll think of those as maybe being rabbits. Y of t is going to be the predator population. We'll think of those as being foxes. Fox. I don't know how to say that, but um, okay. So we want to try to, um, obviously there's, rabbits and foxes, their populations kind of depend on each other. So if you were to write down equations to model these things over time, um, they are going to have an effect on each other. So we're going to come up with a system of equations. Okay, so the first assumption is that in the absence of predators, the prey would thrive. Okay, so in other words, if there weren't any fox around, then the rabbits population would just would be doing really well. It would just keep on increasing. Um, so a way to say that would be dx dt equals maybe ax. Okay, that in other words, that would be like exponential growth. Okay, another assumption we're going to make is in the absence of prey, the predators would die out. Okay, because if there's no rabbits, then the fox have nothing to eat, so their population is going to decrease. So, um, dy dt would be negative. I'll say negative by. Okay. Um, and then the third assumption is that you're going to have interactions. Okay. Interactions are going to be given by an xy term. Okay, x times y. Because if you think about it, if the product of x and y is big, that means that x and y are both big, and so there'd be a lot of interactions. If the product of x and y is small, that means that either x or y, or maybe both of them, are small, so that means there would be very little interactions. And I don't want to get too graphic about what do I mean by an interaction between predator and prey. Um, Interactions are good for the predator, not good for the prey. Okay, so the equations here, the system of equations for the predator-prey model, um, dx dt, I'll write that as x prime. So the prey, it's going to be ax minus, call it cxy. Okay, um, right? If for instance, if y was 0, then x prime would just be ax, which is our assumption. Um, but this interaction, this x times y term, is going to be bad for the prey population. That's why we'd be subtracting cxy. And then y prime would be what? It'd be minus by plus, I'll call it dxy. Okay. Again, our assumptions here, if x was 0, If x was 0, then you would just have y prime equals minus by, which was our assumption. But if x is not 0, then this xy term, these interactions between the predator and between the fox and the rabbits, that's good for the fox population. So that would, that's why you got a plus sign in front of that term with the y prime. So here, this is our predator-prey model. And so what we'll do is we're going to look at a specific example of that. We're going to find the critical points of that system. And then we are going to analyze those in terms of like real life, long-term behavior of these two populations kind of living together.